It is. Okay, so we'll continue from where we stopped like last time. We stopped at continuity, right? So what did we establish last time? Polynomials. Functions are continuous at every point in their domain. What is the domain of a polynomial function? R. Okay, polynomial and rational functions. What's a rational function again? It's a quotient of two polynomials. A rational function is continuous at every point in its domain. And how do I find the domain of a rational function? What do I have? Yes? I have to find the values. The domain consists of the values for which the denominator is under. Thank you. Okay, great. Now we did not discuss continuity from the left and from the right, but we say that f, a function f, is continuous from the right left if in that way we and for left continuity okay, this is the definition of a continuity from the left and right. I don't know if the book makes any remarks on this, but anyways, so this is continuity from the left and from the right. Now it's important, if you have a function, for example, like the square root of x. Square root of x is only defined on one side of 0, right? It's defined on the right side of 0. So if you want to talk about continuity at 0 of square root of x, what definition do you need? You really need this definition. Okay? So, what is that? That's nice. That's some math, I guess. Geometric series. I think that's next calculus course. In the next calculus course, you will see. Okay. Yeah, any questions so far? Any questions? No? Okay. We say that a function f is continuous on an interval if it is continuous at every point Wait, is the handwriting a bit bigger than before, or yeah? Okay. Yeah, I can see that can only fit 2 sentences. So, okay. Yeah, here it's well, that's right there. If f is defined on one side, only one side of point A, number A, then what? Continuity. And we say that f is continuous at A, let's write it. Okay, continuous at A. All the way down. I'll keep this up. Okay. Okay, great. Let's give an example. The function x to square root x. What is the domain of this function? It's defined on, what is the domain? 0 to infinity. Right? Is it continuous everywhere? Well, so what I want to say is that at 0, right, everything else is fine, right? We know that. Now at 0, can I talk about the left continuity or not? No. So really, if you want to sketch that graph of this function, you start at 0, 0, right, and then you go up, right? Do you ever lift your pencil? No. So is it continuous? Yeah. Okay. Very good. And continuous. Infinity. Now sometimes I write the plus, you can omit, okay? When you say infinity, it means plus. Yes?
So if it's not defined to the other side of the point, only the other side?
No need on the left side, no, right? Does it make sense to take a limit as x approaching 0 from the left? Exactly. Okay? Great. Now the book talks about, let us give some example of continuous functions. Or let's start right here. Trigonometric functions. We have polynomials. Rational, polynomial, rational, trigonometric. Trigonometric. What are the trigonometric functions? Cos, sine, tan, secant, cosecant, cotangent, right? We know these? Yeah, we know these or not? Yeah, double angle formula, half angle formula, things like that. Remember these? Please, if you don't remember these, it's good to read the first chapter of the book, trigonometric. So cos, sine, tan. Where is cos defined? Let's do a small, exercise. Cos, where is it defined? On R, right? Sine, R. Tan, is it defined on R? So what point does it miss? So let's start, I'm starting at 0. Does tan of 0 exist? I'm going on the circle, okay? So 0, I am at pi over 2. Does tan pi over 2 exist? I leave pi over 2. Between pi over 2 and pi, does it exist? Okay, until where? 3 pi over 2, okay? And so on. And then you can go backwards to minus pi over 2, minus 3 pi over 2. So it's not defined as multiples at odd multiples of pi over 2, right? This is where tan is not defined. Tan, cotan, secant, cosecant, cotan. What else? Well, inverse trig functions. Inverse trig. What is that? It's arc cos, arc sine, arc tan, blah blah blah. Well, I will talk about arc cosecant, arc cotan. Logarithmic functions. Logarithmic functions. What are the logarithmic functions? Log base b, right? Have you seen that?
Yes.
Log base b. Well, let's write log x. Log base b. I don't know. Okay, so log x, where is it defined? For what values of x? Yeah? You want to say? Oh, okay. Where is it defined? Please raise your hand. Please raise your hand. Ln x, where is it defined? In the back, yeah?
Everything greater than 0.
Everything greater. How is the greater? Strictly greater or equal to?
Greater or equal to.
Okay, so ln of 0. Does ln of 0 exist?
No, not that.
Okay, so it's strictly greater than 0. Okay? This is the domain of ln x. 0. Okay? Thank you. Inverse trig, I don't know if the book mentioned something else. Oh, exponential functions. Exponential functions. So, for example, e to the x, 2 to the x, 3 to the x, blah, blah, blah. Where are these defined? On? Right? Now, by the way, have you seen something that here, can 3 to the x connect with minus 2 to the x or not? Have you seen how we define e to the x or not really? Don't worry about it, okay? We will look only at positive, like e to the x, okay? Like a positive number to the x, okay? Great, awesome. I mean, you can still do an integer to a power of an integer, that's fine. But for when we have non-integer powers, or let's say if I have a real power, I'll just have put a positive base, okay? Great. Are continuous on their domain. No, I forgot something actually. They talk about square root functions. Root functions as well, yeah. Root functions. Square root of x, cube root of x, blah, blah, blah. All of these are continuous on there. So. Okay, very easy. Let's move on to some applications. Or let's take one more theorem. Decomposition. I won't say it. I mean, this is fine. Decomposition of two continuous functions is continuous. Of course, decomposition has to make sense, right? You need the image of the first function to be comprised in the domain of. So if you have f composed with g, it's f of g of x. You need g of x to be in the domain of f, right? All of that I assume that you know. And one more result, another theorem. If f is continuous at b and the limit as x approaches a of g of x is b, then the limit as x approaches a of f of g of x, what do you expect to do? G of x approaches b, right? As x approaches a. F of g of x, where do you expect it to go? Everybody, where do you expect it to go? So this is just f of the limit as x approaches a of g of x, which is f of c. Okay? So far so good? Everybody, so far so good? Okay, great. Now let's move on to some problems. Should we do some problems? Let's do some problems. I'll choose some problems from the book. And let's see. So this is problem 42 from the book, page 125, problem 42. Show that function is continuous on minus infinity. Okay. I have a function here that is defined in a piecewise way, right? It's a piecewise defined function. We agree? Okay. Now, is cos continuous? Cos is a trigonometric function, right? Is it continuous? It's continuous at every point in its domain. Is sine continuous?
Yes.
So it's continuous at every point in its domain, right? Now, this function is continuous everywhere except at possibly one point. What is that one point? 5/4. We all agree this side, right? Yeah? We see that? Now, how do I, so let's try this. I mean, if you have a question like that on an exam, this is how you should, this is how you should proceed, and this is how you should write. So, x cos x and x sin x are continuous on R. Hence, f is continuous everywhere except at possibly what? I'll put it here. Except that possibly that's right. 5/4. Now, how do I check continuity at 5/4? What do I need? Someone else? What? Yes. Yes. Check if the limits are the same, and they should be both equal to f of 5/4. Okay. Do we know how to sketch this graph or not? Or should I sketch it? Should I try to sketch it? Let's try to sketch it. Do we all know how to sketch cos?
Yes.
Cos is something like that, right? This is 5/2. This is 5, right? And sine is something like that, 5/2 and 5, right? You just shift. Do you agree or not?
Yes.
Now this function when the cos and sine intersect at 5/4, right? Right? You guys see that? Now, can I do this without lifting my pencil? Yeah, go there and then go there, right? So, is it continuous at 5/4? Okay, great. I mean, let's check. What is f of 5/4? Everybody, f of 5/4, what is that? Cosine 5/4. What is cosine 5/4? Is, what is that? Who can help me? Okay, one by one. Yes. Radical 2/2, thank you. Now, what is now if x is less than 5/4 and approaching 5/4 from the left, what is f of x? What is f of x? Cosine x. Now is cosine continuous? Cosine is continuous. So what is this limit? This is also √2/2, right? Everybody?
Yes.
Okay, now what do I need to check? I need to check that the limit as x approaches 5/4 plus of f of x is also √2/2, right? Do you agree? Now what is that correct? Is the limit if x is approaching 5/4 plus sine x, what is that? This is also √2/2. So is that continuous at 5/4? Since f of 5/4 is equal I'm writing here is equal to root 2 over 2. So f is continuous at 5 over 2. At 5 over 4, and hence on minus infinity. Okay, great. Let's do one more. What time is it? Oh, okay. Is that accurate? Is it 8:55? Okay. Great. Should we do one more? Everybody, should we do one more? Let's do one more. This is problem 44.
Sorry,
You have a question?
yes,
Yep.
you have to use that wording. So say that we disprove that, then you have to say, like, that is continuous at high over 4, and negative infinity, so we have to put that in or no?
I mean, it's good to conclude, right?
Okay.
And just conclude,
Okay.
right? Just something that finishes off that, you know. Okay? Great. Right? I mean, if you stop here, right? If you stop here, what?
Okay.
You didn't answer really the question, okay? Great. Any questions on this thus far? No questions? On the am I going fast? Is it a bit fast? Okay. I mean, you know that you notice that in high school and university you have in Cégep, well, I mean, most of you did, well, maybe not many of you come from Cégep, but in high school, you know that you have four times the amount of hours, right? So here you have like, how many hours do you have? 40 hours? 40 hours of lectures. In high school you have like maybe 150 hours of lecture per semester, right? Of calculus or of math or whatever that is. Okay, so the rhythm is going to be very, very, very fast compared to a high school, but it's not a big problem because you also have practice questions, right? The amount you spend on practice also, can be factored in the time you spend on the course. So the more practice you do, the better it gets. Okay? And then anyways, if the pace is a problem, the only thing I'll tell you is that you'll get used to it. Okay? So it's important that you spend 2 hours, or let me say, it's important to spend 5 hours, say, a week doing practice questions. Okay? This is very important. That way you can fill the gap that you're missing. Okay, let's do one more example. This is also problem 44. At what point, at what number is f discontinuous? So f of x okay, just let me double check here. 3 minus x. 2 to the x. 2 to the x here. 3 minus x here. And radical of x. X is strictly given. Okay. Now, f is a piecewise defined functions. I have 3 pieces. One of them is an exponential. Is an exponential continuous everywhere? The other one is a polynomial, a linear polynomial. Is it continuous everywhere? And one is a root function, root x, defined for x strictly bigger than 4. Is my function continuous everywhere where it's on the piece it's defined? Yes. Now, where do I have a problem? In general, where is the problem going to be? Possibly. So f is continuous everywhere, except at possibly what points? 1 and 4. So I have to check whether f is continuous at 1 and 4. X, so let's say 50x, and x3 minus x, and x root x are continuous on their domain. So f is continuous everywhere. Except at possibly one and 4. Let us check whether f is continuous at 1. At 1. What is f of 1? F of 1 is f of 1 is what? 2 to the 1, which is 2. Okay. What is the limit as x approaches 1? Minus. Of course, this is just the limit as x approaches 1 minus to 2 to the x, which is 2. Now, what is the limit as x approaches 1 plus? If x is approaching 1 plus, what is f of x? F of x, what is the expression of f of x? Is x is going to 1, but x is strictly bigger than 1. Everybody. Everyone. This side is, good morning. Yeah? x1 plus, where's, if x is approaching 1 plus, what is f of x? X is somewhere here, right? F of x is 3 minus x, right? Which is 2. So if f, is f continuous at 2? The limit as x approaches 1. I mean, the both one-sided limit exists. So, and they're both equal to f of 1. So, since the limit as x approaches 1 minus of f of x is equal to f of 1 is equal to 2, then f is continuous at now, let us look at continuity at what number? 4. What do you guys think? Is it continuous at 4 or not? No. What is f of 4? F of 4 is 3 minus 4, right? Right? F of 4 is 3 minus 4, which is minus 1, right? Now, what is the limit as x approaches 4 of 4 plus of root x? The limit as x approaches 4 plus of f of x. If x is strictly bigger than 4, what is f of x? Root x, right? Root x. This is root 4, which is 2. Are these two equal? No. So is f continuous at 4? So f is not continuous at 4. Okay, so at what numbers is f discontinuous? F is discontinuous only at 4. Okay, let me. F is discontinuous only at 4. Great. Now, that's a good question. Let us do 1 or 2 more. Well, Actually, no, that's good, right? Is that good? Maybe we do one more. Are you, how many of you have taken linear algebra? System of equations. We know how to solve a system of equations with two unknowns. Yeah? Okay, great. Awesome. Do we all know how to do that? System of equations of two unknowns. Elimination, substitution, I don't know what. Yes? Yeah? Okay, great. So we'll just... Okay. Okay. Or maybe that's well, that's right here. Okay. Find the values of A and B. I mean, no, I think this is a long one, so I think try it, okay? I think I put it in suggested questions. I think try it at home. Try it at home. It's a bit long, so I won't do it here. I posted the problem. It's posted the suggested questions. Okay, great. Now let us do some limits. Okay, now evaluate the limit. Evaluate the following limit. X approaches pi over 2 as sine of tan of cos theta. This is also from the book. It's an interesting one. Now, are sine, tan, and cos continuous? They're all continuous on their domain. All I have to check is that cos theta is in the domain of tan. Is cos theta in the domain of tan? Cos theta is between what two values? 1 and negative 1. Negative 1 and 1, right? Is negative 1 and 1 included in the domain of tan? Let's have a look. So what's the domain of tan? The domain of tan, I mean, what's the first part that you see usually? It's minus pi over 2, pi over 2. Union, right? Now is minus 1 and 1 in here? Minus pi, what is minus pi? It's minus 314, right? Divide by 2, you get minus 1 point something, right? So is minus 1 inside here? Is 1 inside here? Yeah? So is tan of cos always defined? Tan of cos is always defined. You agree? Since since minus 1, oh, I have theta. Let me put the theta here. Then tan cos theta is defined for any theta, right? Now, is sine of tan of cos theta defined everywhere? Yeah, because sine doesn't give you a problem, right? Hence, sine of tan and times cos theta is defined for all theta. Now, is it continuous? Is it continuous? Is defined for all theta and is continuous because it's a composition of three continuous functions. You agree or not? Yeah? Everybody? You agree? Great. So what is this limit? Sine of tan of cos theta. What is that? If it's a continuous function defined as pi over 2, how can I plug in the limit? I can just plug it in, right? It's a continuous function. So this is just sine of tan of cos pi over 2. What is cos pi over 2? Cos pi over 2 is 0. Tan of 0 is 0. Sine of 0 is 0, right? Should I write it down? That's fine. Should I write it down or should I give the set? So sine of tan of 0, which is just sine of 0, which is just 0. Okay? So trig and remarkable angles, you have to know them. You have to know them. You won't be provided like a table of trig values, nor will you be allowed a cheat sheet. So like, please know them. They're going to be helpful. I mean, in life they're not very helpful, but in your math exams they're helpful. Okay, great. Any questions? Any questions? Okay, let's do one more now. Evaluate. Okay, have we seen the limit of ln x? Ln x. We did not see it in this course. But what is the limit of ln x? Do we know how to sketch the graph of ln x? Right? What is the limit as x approaches 0 plus of ln x? Minus infinity, right? This is the graph of ln x. You're supposed to have seen that in your free calculus course. So the limit as x approaches 0 plus of ln x is minus infinity. Now what is the limit as x approaches 0 plus of, let's say, I don't know, ln, well, x approaches 1 plus of ln x squared minus 1. What is that? So let's have a look. I have x squared minus 1 as x approaches 1 plus. Do you agree or not? X squared minus 1, where will it go? If x is approaching 1, x squared minus 1, where will it go? 0. Now if x is approaching 1 plus, x squared minus 1 will be positive or negative? Positive. Do you agree? Everybody? Are we following or not? This is the quadratic, right? So if x is approaching 1 plus, then x squared minus 1 is approaching 0. And what can I say about the 0? Is it a positive 0 or a negative 0? Positive 0. Right? So x squared minus 1 is 0. I'm sure we could write 0 there. That's fine. That's fine. I mean, I usually don't like it, but you can write it this way. It is 0 plus. So what ln is continuous? Well, let's not say that. But what is the limit as x approaches 1 plus of ln of this thing that's approaching 0 plus? What is this limit? This thing is approaching 0 plus. So ln of this thing, where will it go? Negative infinity. Do we agree or not? Yes or no? Yes. Any questions? Yes, sir. Yes. You agree that ln as x approaches 0 plus approaches negative infinity. Ln of x. Now, this argument inside the ln, what will happen to this argument? It will be very close to 0 plus, right? A positive 0. So ln of that thing, what will it be? Negative infinity. Is that good? Yeah. Okay, is that clear? Is that clear, everyone?
Yes.
Is that clear?
Yes.
Okay, great. Enough with this. We'll start a new thing. Okay, any questions? Maybe we can take 1 minute of questions. No questions? Yes? Guys? Yes?
Why is the second example without an actual law relevant?
Pardon me?
This last example where it's supposed to look at why is an actual law gone? Why is that relevant?
Here?
Yeah.
This one, I'm just saying that the argument inside the long will go to 0 plus. Right? So the long of that argument that goes to 0 plus will be minus 2. Is that clear or not? You see the argument where the argument goes?
No, I get it, yeah, the 1 squared minus 1 is 0.
Yeah, but it will be positive 0. So that long of that 0 thing will go to minus 2.
Positive 0.
So can the argument inside be negative or not? So draw x squared minus 1. Right? This is x squared minus 1. Now, if x is approaching 1 plus, so your values of x squared minus 1 are going to 0 while remaining positive. Do you agree?
Yeah. So that's why you put 0 plus.
Exactly. And then to define ln, you need the argument to be positive, right? You cannot put the ln of a negative number.
Oh, okay.
Okay? Is that good? Great. Any questions? Any questions? No more? You have one? Sure. Okay. Great. Yes, sir.
What would happen if it's limited x versus 1 from the left?
1 from the left. So ln of x squared minus, so x squared minus 1 will be negative, right?
Yeah.
Can you take a ln of a negative number? This limit does not, like, is not defined even. You cannot talk about this limit. Okay? Yeah? For any theta. So tan is defined where? Minus pi over 2, pi over 2. Union, 3 pi over 2, union, yeah. Pi over 2, 3 pi over 2. Union, 3 pi over 2, 5 pi, right? Now with my cos theta, what are the values that cos theta can take? Minus 1 and 1. So all you need is that minus 1 and 1 to be contained in one of these intervals. Is minus 1 and 1 contained in one of these intervals? It's here, right? So we tan theta defined on this one. Tan defined on minus 1 and 1. So it's defined for any value of theta. Is that clear? 100%? Yeah. It's as if you're saying square root of x squared. That's defined for any x. Why is that? You take the x squared, and the x squared is positive or 0. You can take the root of any number that is positive or 0. Okay? Great. Let's move on to the intermediate value theorem. Oh, I'll write it here. Okay, we have 5 minutes left. Okay, so to be honest, I prefer to do more practice questions than start a new thing. Let's do more practice questions. Let's do more practice, and then maybe you can help me in choosing, in solving them. Okay, everybody. Let's try this limit. Limit as x approaches 2 of 3 to the square root of x squared minus 2. First of all, at x equal 2 is the square root, is the number inside the square root defined? Yeah? At x equal 2, this number is positive, strictly positive. So on either side, x, like this number, is defined. Now, is 3 to the x continuous? X, 3 to the x, is continuous everywhere, right? We agree or not? Now, what is the limit as x approaches to of square root of x squared minus 2? What is that limit? That's an easy limit, right? What is that limit? Square root of 2, right? Now this thing goes to square root of 2. Where does 3 to this thing go to? What is that? Yeah, very good. And I think I messed up. I should have omitted the square root to get a good answer. Yeah. Pardon me? Yeah, you have to say, you have to mention it, okay? You have to mention it. Okay, but the idea is that you can plug in. That's the whole idea, right? Great. Now, should we do one more? Let's do one more. We have like 2 minutes left. Limit. The limit as x approaches 1 plus of ln of x squared minus 1 divided by x minus 1. What is that? Is my thing defined as x equal 1? Is it defined? No, because the thing inside the ln is a rational function, right? And the denominator is 0 at x equal 1. Great. Now what can I do here? What happens here? Can I do something? Yes. Exactly. Thank you very much. Your friend suggested that I factor this up. Now what happens here? What can I do? I can cancel out the x minus 1s. Great. Now if I cancel out the x minus 1s, what is left? Ln of 1 plus x, right? What is that limit? Everybody, what is that limit? 1 plus x approaches 2, right? So ln 1 plus x, since ln is continuous at 2, will approach ln 2. Are we good? 100%. Okay, great. So see you on Wednesday.